Hello students, and welcome to the new session of 2021-22. So today we are going to start with the new session, with the new lecture, video lectures, because you all know that the pandemic situation is still on. So what you have to do is, we will be continuing with the video lectures till any further instructions. Okay. So as we are going to start with the video lectures, there are few general instructions which we have already given you in the previous session. Now in this session also I am going to give you few instructions which you are supposed to follow. And those few instructions are, like, the first thing which you all are very curious about is the syllabus. You are always asking about syllabus. So please this time do not worry about the syllabus. Your syllabus will be given to you within a week or 10 days or so. Okay? Whenever the syllabus will be ready, it will be sent to you. Till then, please concentrate on the lectures. Okay? Now, the second point is, most importantly, that about the copies. Just after the video lecture, you start asking that whether you have to write things in the copy, you have to do the questions in the copy. So yes, you have to maintain a copy. You must have got copies from the school, that I already know that you have got copies from school, and those copies you have to pick up a copy from that lot, and you have to maintain your maths copy. Okay? Now you already know that whatever work we will be doing here in the lecture on the board, okay, that work will be your classwork. You will mention the chapter name, the chapter number, and you will mention their classwork, and then you will do all the sums over there, which we will be discussing here on the board, okay? And the rest of the part which I will be giving, or the other teachers will be giving as homework, that below itself you will draw. Once you finish the classwork, you will draw a line, you will put up their homework, you will mention the heading homework, and there you will do the questions given in the homework. Okay, so this is something about the maintenance of the copy. Now, please remember that you have to write very neatly in your copy. Your work should be legible enough so that the teacher could understand that what you have written. It should be neat and clear enough. Okay? Now, the second thing is that please keep your work updated. Do not leave today's work for doing it tomorrow or day after tomorrow or after a month like you did last year. This will not be tolerated. You have to keep your work updated. The day we send you a lecture, the same day, go through it, complete your classwork, complete your homework. I'm sure you will follow this. Because you need to follow this actually. Because your copies will be assessed. Fine? You know that you have some marks on your copies. And this time your copies will be assessed, not like last year. This time it will be assessed. Your copies will be asked from time to time for correction. Please keep these general instructions in your mind. And with this, now we are going to start with the very first chapter of maths. The very first topic in your maths book is concept of set. Okay, so today we are going to discuss few definition of set, and few other things related to set, the basic things. I hope you might already be knowing few things about set. So we will start first of all with the definition of set. So students, when you will open your book, you will find out the very first thing, that is the definition of set. That is, what is set. Then you will find a line written over there that a set is a collection. Okay, a collection. What type of collection? Not just a collection. A collection of well-defined. A collection of well-defined and distinct objects. well-defined and distinct objects. Now, what we are supposed to understand is that what is this well-defined and what is this distinct? Okay, so let us try to understand that what is well-defined and what is distinct. Okay, so see, if I have written a set of first 4 natural numbers, okay, so a set of first 4 natural numbers. So what are the first 4 natural numbers? 1, 2, 3 and 4. So don't you think so that when you read this first 4 natural numbers, the only 4 numbers which will come to your mind will be 1, 2, 3 and 4. No other number would come to your mind. Okay, so can you see that this is well defined? Isn't it? Well defined and distinct too, because no other number would replace these 4 numbers. The first 4 natural numbers would always be these 4 numbers, 1, 2, 3 and 4. So this is well defined and distinct. So we can call this collection a set. If you write it this way, I'll tell you why it is written inside the brace. Okay, so this is a set. We just discussed about well-defined and distinct object. Okay, like I have given you an example of a set of first 4 natural numbers. I have written first 4 natural numbers. Okay, so this was the collection of these numbers was definitely, you saw that these numbers, the collection of these numbers was well defined and distinct. Now let's take another example where if I write consecutive even numbers, okay, if I write 4 consecutive even numbers. I hope you understand that what is consecutive. Consecutive, that comes one after the other, and even you all might know. Okay, so now if I say 4 consecutive even numbers, so 4 consecutive even numbers could be 0, 2, 4, 6, isn't it? If suppose all of you are there in the class and if I ask one of the child, tell me 4 consecutive even numbers, the child would say 0, 2, 4, 6. Another child could get up and say that no miss, it would be 4, 6, 8 and 10 also. Isn't it? 4, 6, 8 and 10 also. Another child would say that it could be 8, 10, 12, 14 also. These are all consecutive only and these are all even numbers. Isn't it? But could this be called as a set? If you write 4 consecutive even numbers, will this be called as a set? No, it cannot be called as a set. Why? Because the objects are not well defined. Why they are not well defined? Because in one set you can write 0 to 4, 6, 8, 0 to 4, 6. Another set could contain 4, 6, 8, 10. This particular definition could give you different numbers in the same set. Isn't it? 0 to 4, 6 are also 4 consecutive even numbers. 4, 6, 8, 10, these are also consecutive even numbers. Then 8, 10, 12, 14, these are also consecutive even numbers. So this is not well defined, isn't it? You do not have a particular answer for this. So this is not well defined. Neither it is distinct. Could see the digits, okay? This is not well defined and distinct. This does not contain well defined objects. So this is not a set. This is not a set. But this one is a set. So I hope you must have understood that what basically well-defined and distinct objects mean. Okay? I hope this is clear to you. Now, one more example I would like to give you. See, if you write here log down. Okay? If you make a set of the words, of the letters of the word lockdown, so Why? Because we have just studied that a set is a collection of well-defined and distinct objects. So the letters of the word lockdown here, you can see that O is getting repeated. Okay, so in a set, each of the object should be distinct. Distinct means it should not get repeated. It should not repeat itself. But here you can see that it is repeating itself. Okay, so this is not the set. Although if you would have written it as L O C K D W N, so this would be here. Each and every element you can see that the elements are distinct. They are well defined and distinct. See, the elements are not getting repeated. Okay, so I hope the basic definition of set might be clear to all of you, and the words used in the definition of set, that is well defined and distinct, now that might be clear to all of you. Now let us talk about a few more things, that how do we how do we name the set, how do we represent the set, about these things. Okay. So students, we name the set with a capital letter. Okay, when we say a set A or a set B, we always represent the set by capital letter. Set A. Okay, and the elements of the set, that means whatever objects belong to the set, those are always written inside curly bracket. Okay, so if I say a set A, suppose a set A is a set of first 4 odd numbers. A set A is a set of first 4 odd numbers. So what will be the set? How you will write it? You will write it as set A, capital A. Okay, and then what will be the elements of the set? Because it's first 4 odd numbers, so obviously those would be 1, 3, 5, 7, isn't it? But the way of writing the elements of the set is to write them inside a bracket. Okay, inside a curly brace. Okay, so we write it as 1, 3, 5, 7. I hope this might be clear to all of you. This is how we represent the set. Okay, how we represent? We write set A is equals to, then we write the curly bracket and the elements. These are called the elements of the set. What are they called? The elements of the set. I hope this might be clear to all of you. Now, you can see that 1, 3, 5, 7 are the elements of the set. So how do we write? We write 1 belongs to set A. Okay? This is the sign. We read it as belongs to. So 1, you can see that 1 belongs to A. So we can write 1 belongs to A. We can write 3 belongs to A. Isn't it? 3 is an element of A. So we can write this 3 is an element of A. 3 belongs to A or 3 is an element of A. This is how we read it. Now if you can see, if I write 2, is 2 an element of A? Obviously not. 2 is not an element of A. So how we will represent? 2 does not belong to A. I hope this particular thing might be clear to all of you. Okay, this is how we name the set. We always write the name of the set with a capital letter. Now, see, the name of the set could be anything. A, B, C, D, X, Y, Z, anything. Okay? Now, see, there are some special notations for some types of set. Like a set of natural numbers. A set of all the natural numbers is always represented by capital N. Okay? So, if I say 5, is 5 a natural number? Yes. So, 5 always belongs to capital N. If I say minus 1, is it a natural number? No. So, minus 1 does not belong to capital N. Okay, so this is how by N, using N, we denote a set of natural numbers. This is special notations. Okay. And capital N represents a set of natural numbers. Then capital W represents a set of whole numbers. Okay, capital W is always represents a set of whole numbers. Now the set of integers is represented by the letter either I, or you can also write Z. This is used for the representation of integers. A set of integers. Okay. So if you pick up any integer, if you pick up -1 or -5, suppose if you pick up -5, so -5 does not belong to natural number, isn't it? -5 does not belong to whole numbers, but -5 always belongs to integers, isn't it? It's always an element of the set of integers. I hope this is clear to all of you. These are special notations. These are the special names given to few of the set. Okay, a set of natural numbers is capital N, a set of whole numbers is capital W, and a set of integers is represented by capital I or capital Z. Anything, whatever you like. I hope this might be clear to all of you. Now, let us move on how to represent a set. See, there are two different ways of representing a set. Okay, let's see. Let us now see how to represent a set. See, a set could be represented in two ways. The first one is the roster method. Roster method, or we call it as the tabular method. Tabular method or tabular form. Okay. We represent the set in first way is roster method or tabular form. The second one is set builder form. Okay. Rule method or set builder form. Okay, these are the two methods through which we can represent our set. First one is roster method or tabular form. The second one is rule method or set builder form. Now, how do we represent the set using these two methods? That we'll see one by one. Okay, so let's begin with the first one, that is the roster method or the tabular form. See, in this case, suppose if it is written, I am taking always the same example so that you can understand everything with the same example. Okay, again I am taking the same. A set of first 4 natural numbers. If I have written A is equals to a set of first 4 natural numbers, that means there is a set A which is a set of first 4 natural numbers. How we will represent it? Using roster method or tabular form. See, in case of tabular form or roster method, the elements of the set are always written inside a brace. Okay, the way we have studied. Okay, the first 4 natural numbers would be 1, 2, 3 and 4. So this is how we represent a set in tabular form or roster method. It is all the elements are written inside the curly brace. I hope this might be clear to all of you. Now, if we talk about the set builder form, the second form, the set builder form, or the rule method. If you have to represent the set in the set builder form or the rule method, how do we represent the set? Let's see if we have to represent a set using set builder form. How we will do that? Okay, so in case of set builder form, we always write the common properties. We pick up the common properties of the element and we write inside the set. Like suppose if we have to write a set in set builder form, and the set is a set of What elements are there? See, we don't have to write the elements now. The elements are written. If suppose we have to write the same set in the tabular form, what you would have written? You would have written it as A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are the first 10 natural numbers, and this is how we represent it in the roster form or the tabular form. But in case of set builder form, how we will write? See, we will not write the elements exactly. What we will write? We will represent the element by some alphabet, by A, B, C, D, X, M. Here we have taken as X. Okay, A is equals to X. Then we always draw a line. What does this line represent? Such that X, such that X is an element of natural numbers, isn't it? The elements of this set A has to be a natural number. So this is why I have written X such that, what is X? X is an element of natural number. Then we have to be very precise. We have to give the elements. We have to tell that the elements are distinct also and well defined also. We have defined the element that this is natural number, a set of natural number, but a set of natural number till where? X such that X is an element of n and X is less than 10, isn't it? X is less than 10. We can write it as X is less than equal to 10. Okay, X such that X is an element of n, that means X is a natural number, and X is less than equal to 10. That means here if you read it, what you will understand that this is a natural number. That means it's going to start from 1. Because there is no constraint that this has to be greater than something. It is just natural number, that means, and it is not greater than any other number. So it will start from 1 only, 1, 2, and it is less than equal to 10. So it will go up to 10. I hope this is clear. How we have written this? We have written this part by using the common property. And what was the common property between the elements? The common property between the elements was that these were the elements of natural number, isn't it? And this was less than equal to 10. This is how we represent the set builder form. I hope this might also be clear to all of you. Now, we will be talking about some types of set. I hope students this is clear to all of you. We will be solving questions related to this and then it will be more clear. Okay, now let's talk about types of set. There are different types of set. Let's talk about them. See, the first type of set which we will be talking about is finite set. Finite set. Okay. Now, before understanding what is finite set, you can understand that if there exists a finite set, definitely there might be existing an infinite set. Okay. Now, first of all, let's talk about finite set. So, what is a finite set? See, by the word finite, what do you understand? You understand that the elements might be countable, isn't it? It could be counted up. Okay. So, if a set has, suppose A is equals to, you write it as 3, 5, 7 and 9. Okay. So, what are the number of elements in this? The number of elements is 1, 2, 3, 4. So, this set has 4 elements. So, this is finite, isn't it? Now, if I write a set M as a set of natural numbers. So, a set of natural numbers would be, if I write set N is equals to a set cannot count them. Isn't it? So this is an infinite set and this is a finite set. I hope this might be clear to all of you. Now, there exists one more thing, which is cardinal number of set. Okay, cardinal number of set. Because I have told you finite set over here, so here only I am going to tell you what is cardinal number of a set. See, in case of infinite set, you cannot count the elements. Now let's talk about cardinal number of a set. What is cardinal number of a set? See, it is first of all represented by small n. Small n of A. Okay, how do we represent? Small n of A. Okay. If you have to find out the cardinal number of A, so this is n of A. Cardinal number of A. And what is it? See, cardinal number of a set is the number of elements of the set. So how many elements are there in this set? There are 4 elements. So what will be the cardinal number of A? So n of A, that means the cardinal of A would be 4. I hope this might be clear to all of you. Cardinal number of a set is always the number of elements in the set. Okay. Now if you have a set of the letters of, suppose, if I write my name. Okay, my name is Sucheta. Okay, Sucheta. I hope this might be clear. This is a set. Okay, this is a set. Suppose this is a set L. Okay, this is a set L. And the elements are distinct enough, isn't it? Sucheta. Okay. Now, what is the cardinal of set L? What is the cardinal number of set L? 1, 2, 3, 4, 5, 6, 7. The cardinal number of set L is 7. I hope this is clear to all of you. Now, having discussed finite set, infinite set, and cardinal number of set, let's talk about empty set. Then what is an empty set? What is an empty set? So I hope by the name itself might be clear to all of you. This set will have no elements. Okay, this set will have no elements. See, like if there is some set A and there are no elements in this set. Okay, there are no elements in this set. So this will be written in this way, in this form. Only the brace will be made, the curly bracket will be made, and no element, because it does not contain any element, so nothing will be written inside this, and this represents an empty set. Okay, an empty set is always represented by this file or a empty brace. If you find a file or a brace, okay, you will understand by seeing this only that these are empty sets. Okay, to understand more about empty sets, let's take an example. An example which is already given in your book. I am taking the same example where a set A is equals to x such that 2x plus 1 is equal to 0 and x is an element of whole number. Okay, so x has to be a whole number, and when you put the values of x here, the value that should be, whatever answer you should get, that should be equal to 0 always. Okay, so first of all let's see, 2x plus 1 is equals to 0, it is written. Okay, now let's solve this. You know already how to solve it. 2x, if you transpose this 1 to the other side, this will become 0 minus 1, isn't it? And this x is equals to minus 1 by 2, isn't it? Minus 1 by 2. Now students, if you can see that here we have got x as equal to minus 1 by 2. But here it is mentioned in our set that x is an element of whole number. Can you see that this is not a whole number? This is minus 1 by 2. Can you ever imagine that a whole number to be negative? Or if you even remove the minus minus sign, this is a fraction, isn't it? And if you put up the minus sign, this is a rational number, isn't it? This is a rational number. We'll talk about rational numbers later on. So first of all, you just see the minus sign. We cannot have a whole number with a minus sign, isn't it? So this is not a whole number. So, but in our set it is saying that x has to be a whole number. So this means A is an empty set. It will not contain any element, isn't it? So we can write that A is an empty set. Isn't it? A is an empty set. Understood? I hope the concept about empty set might be clear to all of you. Now, let us move on to what are universal set. You will come across this word universal set a lot of times. Okay, so let's try to understand what is a universal set. So now what is a universal set? See, universal. Okay, something which contains everything here. By the word universe, what do you understand? In universe, we have everything inside the universe only. Okay, so here also, universal set. Everything inside one set. Okay, let's try to understand this. See, suppose A is a set of first 4 natural numbers. So A will be equal to 1, 2, 3, 4. Okay. Now let's suppose that set B is a set of first 4 whole numbers. So set B would be 0, 1, 2, 3. Isn't it? Now let's take set C as a set of first 4 odd numbers. So first 4 odd numbers would be 1, 3, 5 and 7. Okay, these are the sets. Okay, now you can see that this set has 1, 2, 3, 4, this set has 0, 1, 2, 3, 4 and this set has 1, 3, 5 and 7. Okay, now what would be the universal set? First of all, let's see how to represent a universal set. A universal set is always represented by U or a sign made like this. Okay, first of all, a universal set is represented by this way. Okay, now what does the elements of universal set contain? What does the universal set contain? What are the elements of universal set? So, universal set is always equal to, it always contains all the elements of the set which are being considered. Like here we are considering 3 sets, set A, set B, set C. So universal set will have all the elements of all these sets. Okay, like universal set will have 0 also, it will have 1 also, it will have 2 also, it will have 3, 4, 5 and 7. Can you find any element in these sets, in this set A, set B or set C which is not in universal set? And A has 1, 2, 3, 4, it is there in universal set also, 1, 2, 3, 4. B has 0, 1, 2, 3, universal set also has 0, 1, 2, 3. Set C has 1, 3, 5, 7, set universal set also has 1, 3, 5, 7. So universal set basically is a set of all the objects. Okay, a set of all the objects which are being considered. Okay, if you have many sets, all the elements of those sets would be inside the universal set. So I hope this might be clear to all of you. And how do we represent this? Either we write U or we write it as this way. Okay, these are the ways how to represent universal set. I hope this might be clear to all of you. Now let's talk about equivalent set and equal set. Equivalent set. So what is an equivalent set? See, suppose set A is an element, set A has 0, 2, 4, 6. These are the elements of L, M, N, O. Okay? Now if you can see, A has 0, 2, 4, 6, B has L, M, N, O. Okay? Now if you find out the cardinal of A, what is the cardinal number of A? As I have told you, cardinal number of a set is the number of elements in the set. So here 1, 2, 3, 4, there are 4 elements. And what is the cardinal number of B? What is the cardinal number of set B? L, M, N, O. 1, 2, 3, 4. This is 4. You can see that set A also has 4 elements, set B also has 4 elements, isn't it? So these sets, any two sets which have the same number of elements. Remember, I am not talking about the same elements. Here I am talking about the same number of elements. The cardinal number, if the cardinal number is same, then those sets are called as equivalent sets. And how are they represented? They are represented as A is equivalent to B. And when A is equivalent to B, always the cardinal of A would be equal to the cardinal number of B. I hope this might be clear to all of you. Now let's talk about equal set. See children, equivalent set is about the number of elements. Okay, the number of elements should be same in equivalent set. Now if you talk about equal set, what is an equal set? So in case of equal set, the elements should be same. The elements of the set should be equal. Like here, if set A has 1, 2, 3, 4. And the elements of set B also are 1, 2, 3, 4. Then such sets are known as equal set. Why? Because the elements are all same in both the sets. So such sets are known as equal set. I hope this might be clear to all of you. Here set A is equal to set B. How do we represent it? Simply A is equal to B. Set A is equal to set B. Because the elements are all same. Okay students, I hope with this all the definitions, all the basic concept of set might be clear to. We will be taking up the exercise 1A, which is related to these concepts only. We will be solving questions related to these concepts in that exercise. Till then, please do go through these concepts and be ready to solve the questions.